Hello friends, my name is Sushil Pandey. Welcome to my networking video series. Today topic Network Essential Book. In this part, today we will talk about TCP/IP services and TCP/IP tools. Let's start TCP/IP services and tools.
TCP/IP services and tools. Worldwide, organizations want seamless connectivity between the hosts within their networks, so that they can communicate with each other and share data and resources. For this, the hosts require IP addresses. However, allocating an IP address manually in a large network is cumbersome. Therefore, a TCP/IP service called DHCP is used, which provides an automatic way of assigning IP addresses to hosts. Moreover, users also need to connect to various servers for accessing network services, such as data storage and the Internet. To access these servers, users need to remember the server's IP addresses, which are in numeric format and may be difficult to remember. Therefore, there is a need of another TCP/IP service called DNS, which enables network resources to be accessed through their names, not by their IP addresses. In addition, to make network services always available, network administrators need to use various TCP/IP tools. These tools are used to test, diagnose, and monitor network connectivity. This chapter discusses TCP/IP services and TCP/IP tools. Objective: in this chapter, you will learn to identify TCP/IP services, identify TCP/IP tools, identifying TCP/IP services. Consider the scenario of X2Y technologies. The organization's users need to access network applications and services frequently. For this, they need to use IP addresses, which provide unique identification to network resources, such as servers, desktop computers, and devices. Identifying the DHCP service. DHCP is an IP standard that simplifies the process of assigning IP addresses to desktops in an organizational network. It helps to dynamically assign IP addresses to all the desktops connected to the network. DHCP uses a client/server model whereby the client's request for IP addresses and the DHCP server allocates unique IP addresses to these clients. It offers the following advantages: automatic TCP/IP configuration. DHCP helps you configure TCP/IP settings automatically for all the clients in a network by assigning an IP address to each. In addition, DHCP minimizes the errors that might occur due to manual TCP/IP configuration. Centralized TCP/IP configuration. DHCP provides a centralized TCP/IP configuration structure to all the clients in a network. This helps in managing the TCP/IP configuration of all the network resources easily and efficiently. Dynamic allocation of IP address. DHCP assigns IP addresses to its clients dynamically for a limited period. Identifying the tasks of a DHCP server. When clients request for IP configuration, the DHCP server performs the following tasks. It leases IP addresses to the clients, based on a specified period called lease, which is configured by the administrator. When the lease for IP addresses expires, the DHCP server automatically renews the IP addresses. A DHCP server renews the IP address when the client explicitly requests for IP address renewal. It updates DHCP client parameters, such as the default gateway and DNS servers automatically. This is done at the DHCP server by the administrator who sets the DNS server and allocates scope for IP addresses. This is beneficial as the parameters do not need to be updated separately on all DHCP clients. Identifying the DNS service. DNS is a name resolution service that resolves host names to their respective IP addresses. When a DNS server receives a request to resolve a host name into its corresponding IP address, the DNS server first tries to resolve the IP address locally. At this time it uses the information stored in its own name server. If the DNS server cannot find the IP address to be resolved, it forwards the request to another server. This process continues until the resolution takes place. For example, if a Identifying common TCP/IP tools. Consider the scenario of N. Stevens Incorporated. Sam, the network administrator, has set up the initial network by connecting computer systems and setting up the DHCP server to assign IP addresses to the hosts. Sam wants to ensure that the computer systems are connected to each other to form a proper functioning network. However, he is also aware that there might be problems, such as a network cable unplugged from a computer system, which can block communication between the computer system and the rest of the network. To ensure seamless availability of a network, Sam needs to use various TCP/IP networking tools that help to monitor network connectivity and ensure that any network issue is diagnosed and checked before there is an event of loss of business. Sam also needs to use specific third-party TCP/IP tools such as protocol analyzers and throughput testers to manage network traffic and ensure network security. A protocol analyzer is a software or hardware tool that is used to capture data packets to analyze signals and data traffic over a communication medium. It works by sniffing each packet passing through the communication medium and then decodes the packet's raw data. A protocol analyzer also analyzes the content of the packet to detect packets, if any, sent by unauthorized users with malicious intentions to intrude into the system. Similarly, a throughput tester is used when you need to test the network's capacity and throughput. In computer networks, throughput is the average rate at which messages or packets are delivered over a communication channel. It is measured in bits per second, which is denoted by bps or bit/s. Therefore, Sam decides to use the following TCP/IP tools. IP protocol configuration, ping, trcert, path ping, protocol analyzer, throughput tester, ANS lookup, ARP, netstat, entstat, root. Understanding the IP protocol configuration command. The IP protocol configuration command displays the TCP/IP configuration of a computer for a Windows OS. It enables users to determine TCP/IP configuration values for the system. The configuration may be set manually or through a DHCP server. The IP protocol configuration command is executed at the command prompt by using the following syntax. IP protocol configuration. The IP protocol configuration command returns the IP address, the subnet mask, and the default gateway of the computer, as displayed in the following figure. The output of the IP protocol configuration command at the command prompt. The following table lists various options of the IP protocol configuration command and their description. Some options used with the IP protocol configuration command. In the Linux OS, the ifconfig command is used to display the TCP/IP configuration of a computer. Understanding the ping command. The ping command checks the connectivity between a computer and remote hosts. The utility returns the status of the connection with the remote host. The ping command is executed at the command prompt by using the following syntax. Ping destination. In the preceding command, destination means the IP address or the host name of the target machine. The following figure displays the output of the ping utility. The output of the ping command at the command prompt. The ping command can be used along with different options. The following table lists some of these options and their description. Some options used with the ping command. Understanding the trsert command. The trsert command is an advanced version of the ping command. It uses the ICMP echo request messages to determine the path of the routers and gateways that are closest to the source host. The trsert command shows the routers in between the sender and receiver computer, as displayed in the following figure. Understanding the path ping command. The path ping command is used to trace the route from a sender to a receiver computer. It combines the features of the ping and trsert commands and provides extra information, such as the router that is causing maximum data loss. Path ping calculates the amount of data loss at each router by sending packets to each router on the way to a final recipient computer over a period of time. Then, based on the output that has returned from each router, it computes the number of packets lost at any given router or link. This helps in determining the routers or links that are causing network problems, such as data loss. The path ping command can be used along with different options. The following table lists various options of the path ping command and their description. Some options used with the path ping command. Understanding the nslookup command. nslookup is a command line tool, which is used for administrating, testing, and troubleshooting DNS servers. It has the following two modes. Understanding the ARP command. The ARP command maps or resolves a logical address of a node to its corresponding physical address. Every node of the network and the router maintains a table in its cache, which contains a list of IP addresses and respective hardware or MAC addresses of the devices that exist on the network. This table is called ARP cache. A router or a node refers to ARP cache when it is determining the hardware address of a device for which it knows the IP address or logical address. If the hardware address is not found in the ARP cache, then an ARP broadcast is sent on the network. Every node in the network, including the destination node, reads this broadcast. The destination node unicasts an ARP reply with its hardware address so that the router or node can forward the IP data packet to it. To view the ARP cache, you need to run the following command. ARPA. The output of the preceding command is displayed in the following figure. The output of the ARPA command. The ARP command can be used along with different options. The following table lists some of the options of the ARP command and their description. Some options used with the ARP command. Understanding the netstat command. The network statistics, netstat, command is used to display protocol statistics and current TCP/IP connections. It displays all active TCP connections along with the TCP and UDP ports, which are currently engaged in sending or receiving packets. It also displays the IP routing table in addition to the Ethernet statistics, such as the number of packets and bytes that have been sent and received. When the netstat command is used with the S parameter, it displays a brief report of the statistics of the protocols, such as TCP for IPv4 and IPv6, UDP for IPv4 and IPv6, ICMPv4, ICMPv6, IPv4, and IPv6, as displayed in the following figure. The output of the netstat S command. The netstat command can be used along with different understanding the ntstat command. Ntstat is a Windows-based command line tool that is used to troubleshoot network basic input-output system, NetBIOS, names to TCP/IP addresses resolution problems. NetBIOS names were used in legacy applications. Ntstat acts as an interface between the application that uses the NetBIOS name and the user that uses the IP address. NetBIOS name resolution is done by TCP/IP by looking up the local cache lookup, querying the Win server, broadcasting, querying the DNS server, and looking up the name in the LMOS and hosts file. The ntstat command can be used along with different options. The following table lists some of the options of the ntstat command and their description. Some options used with the ntstat command. Understanding the root command.